Hi, it's time for the math easy solution. Trying to discuss further into integrals and volumes by cylindrical shells, and now look at example 3 of this example series. I'm going to solve this example, which states use cylindrical shells to find the volume of the solid obtained by rotating about the x-axis the region under the curve y equals square root of x, or y, yeah, just write it like this, from 0 to 1. Now the difference between this example and my earlier examples is that we're rotating about the x-axis and not the y-axis, and in this example I'll show that it doesn't matter which axis, you could still use the cylindrical shells method. Yeah, but in this case we're going to be dealing with in terms of y instead of in terms of x when we do the volume integral. So now if we draw the x and y axis and draw our region, so this is the square root of x, it's going to look something like that. This is y equals square root of x. And now, so basically from 0 to 1, so if we draw it across from here, this is 1, there's 0, so now there's our region. Now when we rotate it about this x-axis, we would get something like a shape that looks like this. It's just a cone shaped. So it looks, yeah, basically this is our solid right here. And now when we want to find this point, which is the height right here, this is at y of 1, that equals square root of 1, that just equals to 1. We'll use this in our volume integral. Yeah, so now we're going to draw our shell at a random point. Let's just pick this point right here. This is at x, and now at this point right here, this is going to be our y. So that's our y, there's our y, there's our x. So now when we draw a shell, it's going to be in between this function right here over this vertical line. In this case, we'll call this x equals 1. So that's just a vertical line across, and now our shell is going to look something like this. So again, this y is at the center line all the way across here. So there is our thickness of our shell, and now this height right here is equal to, or this horizontal height is just 1 minus this x. So this changes the variable, but this 1 is always there. So if it's here, you're going to have a different height, etc. So now when we draw the shell, it's going to look something like this. So it would look something, whoops. Yeah, whoops. Anyways, so it looks something like this, all the way across. And there's our shell. Yeah, and I'll draw a dashed line across. Yeah, so there is our shell. So we know the height, we know the radius, which is y, and now and also the thickness right here, which is delta y. And now this height right here, this is a horizontal height, 1 minus x. This equals 2, 1 minus, now this x, we could write it as in terms of y, just square both sides, so we get x equals y squared. So this is just y squared. So we're writing everything in terms of y, and the reason for that is because we're dealing with rotating about the x-axis, so we're going to be writing the volume integral in terms of y. So we go from volume integrals now from 0 to 1, whereas from 0 here up to 1 here, of now the circumference of this shell, which is 2 pi times the radius, which is y right here. So 2 pi y times by this horizontal height, which is 1 minus y squared, and now times the thickness, which is delta y, but we're dealing with integrals, so the infinitely small thickness dy. Now this equals 2, just simplify this further, take the constant 2 pi out, and just multiply this y inside, so from 0 to 1 of y minus y cubed dy. Now we could solve the integral. This equals 2 pi bracket, this is going to be y squared over 2, that's the integral of y, and now integral of y cubed is going to be y to the 4 divided by 4 from 0 to 1. Now we can just plug in the 1, So we get 2 pi, and now we ignore the 0 because that's just going to cancel. Everything's going to be 0. So 1 over 2 minus 1 over 4. Now we write the common denominator, which is 2 over 2. And that's just going to be 2 minus, 2 over fourths minus 1/4. That just becomes, I'll just write it for completeness, 2 over 4 minus 1 over 4 equals 2. This is going to be now, that's just going to be 1 over 4. 2 pi over 4 equals 2 pi over 2. And that is our final answer. And yeah, and just wanted to point out that in my earlier video when I did this one, solve this exact region using just disks instead of these shells, it was actually easier than this method. Just wanted to point that out. Anyways, that's all for today. Hopefully you learned from this video, and like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another math easy solution.